In previous video, we saw that how the variable coefficients are treated. In this video, I give you an example where the coefficients are variable. Here you can see an example of advection equation which has a variable coefficient, and there is initial condition and there is an boundary condition. We write equation 1. I need to solve this equation. So we write equation 1 as partial u by partial t 1 over x partial u by partial x is equal to 0. As we developed a theory about characteristics, that all the information travel on the characteristics. So for that, what we do, we write u is equal to constant. Remember that here q is equal to u, and the coefficient is, this is coefficient, which is also a function of 1 over x. Okay, so u is constant when dx by dt, and you remember that it was u which is a function of x, and here u of x is equal to 1 over x. Now what I do, I solve this differential equation. I multiply both sides with dx by dt 1, and then I integrate by multiplying dx over dt with dt, and this definition on the left hand side becomes x dx dt, and the solution will be x squared by 2 is equal to t plus constant. So t will be equal to x squared by 2 plus constant. These are the characteristics, and these characteristics are parabola. As you can see, this is a parabola. We will talk about that very soon. Now there are two situations where the characteristic has t is less than or equal to x squared by 2. In that case, for example, let me just show you the image. This is the image. You can see that this curve, characteristic curve, is t is equal to 1 by 2 x squared. On the y-axis you have t, and on the x-axis you have x. On the y-axis t, and on the x-axis is x. Cx, you can see from the initial condition, when t is 0, u of x is cx. So c of x has been shown over here like this. And similarly, for boundary condition x is equal to 0, we have b of t. So all the solution, boundary condition solution, is over here. And these are all the characteristics. I draw this particular characteristics over here again. This is a characteristic. And these are other characteristics. There are many characteristics over here, like parabola. And there are two situations. One situation is when t is greater than, which I will discuss in the theory, t is greater than x squared by 2. In this case, we have all these characteristics. And these characteristics, you can see that these are passing through the t-axis. These are passing through the t-axis. These are all characteristics that are passing through the t-axis where we have b of t. Similarly, when t is less than x squared by 2, in that case, we have all these characteristics, this one and this one, these are all passing through the x-axis, on x-axis. And you know that on x-axis, t is 0, and on t-axis, x is 0. So, so we discuss the situation over here. If t is less than or equal to x squared by 2, and consider any point x1, t1, so the characteristics passing through t minus t1 is equal to half x square minus x1 square. We have to first just write this equation. Otherwise, you will get confused. I have to use this equation later on, this partitioning of the characteristics later on. So we just say that there is a point x1, t1, and the characteristics are passing through this point r is this equation. This is the equation. T minus t1 half x square minus x1. When you put x is equal to x1, t is equal to t1, you get 0. So the characteristics is passing through this point. Now if we say that if this t1 is less than or equal to x1 square, these are the characteristics, and we have chosen any point over here. It can be here, it can be here, it can be anywhere. And the later on, when we say that this is x1, t1, then we consider t1 is greater than half x1 square. T1 is less than or equal to x1 square. In this case, if the point is here, I should say, if the point is over here at this point, x1, t1, and this characteristics is passing through which axis? It is passing through x-axis. If it is passing through x-axis, then x will be equal to x naught and t will be equal to 0. So the above equation become minus t1 half x naught square minus x1 square. And we solve this equation for x naught, and x naught becomes x1 square minus 2t1 under root. So this is that solution when we have characteristics passing through the x-axis, and it is only possible when we have t1 is less than or equal to half x squared. Now the second situation is if t1 is greater than x1 squared by 2. Suppose we have a point over here x1 comma t1, then this t1 will be greater than half x square. In this case, the characteristics, this characteristic is passing through the y-axis, which is a t-axis. Then this is t naught, this is t naught, this is t naught, so on. Similar to when on x-axis we have x naught, so on. So we replace this equation with t is equal to t naught. This becomes t is equal to t naught minus t1 minus half, since x is equal to 0 on t-axis, x is equal to 0. So we get minus half x1 square. So t naught will be equal to t1 minus half x1 square. So we have two situations. One situation is for x naught, another situation is for t naught. If you don't understand that, then I request you to watch the video again and try to understand this concept. This is very important. It means that x naught, when we have x naught over here, then you have to use c of x. When we have b of t, then we have to use t naught. So the solution will be, the solution will be, solution of, solution is, since we know that ux1 t1 u0 t is equal to t naught will be equal to b of t naught. So ux1 t1 b, and put the value of t naught, that will be t1 minus half x1 square. Since where is t1? When we get t naught, we put the value of t naught over b into the b. So we have this solution. In another scenario, the complete solution is u of xt if t is less than or equal to x squared by 2. Then we have x naught. So we have c x naught. X is equal to x naught, and x naught is equal to this value. So that becomes x squared minus 2t. We are actually dropping the subscript. So that becomes b, and for t is greater than x squared by 2. So maybe we say that t is less than or equal to x squared by 2 is one situation, and t is greater than x squared by 2, and t is less than or equal to x squared by 2. That is another situation. When we have x naught, for example, this is x naught, we put that value into the b, 1 minus x squared by 2. Yes, I have to just take a look b. What is for t greater than, we have this value. And If we put the value of b t naught, what is t naught? T naught, t1 minus half x squared, correct. It should be t naught. I was thinking I just written a wrong thing over here. So this is t. And for c, since this is c and c is on x-axis, and when there is x naught, we put the value of x naught, which is already defined over here. So this is the final solution of this advection equation. Thank you for watching.